Hi everyone, welcome. I'm Gabriel. I worked on sensorCFD. It's a super nice project that I dreamt to do while I was doing my PhD. Today's presentation, I will try to go short. So it would be a short presentation, about 5 minutes. Then after that presentation, a small question session. And then I will have sorry, and then I will present a case. Today version is a bit different because Nicola will show some feature too. So and in the end, another session of question. So you will feel free to ask questions. Okay, so what is CFD? CFD use a real equation to follow the physics of your case. So it's not a black box, it's not machine learning, it's a real equation that exists since the 19th century with a proven numerical method. In fact, both were existing before computer. So right there, it's a NASA computing room where people were computing each element by hand. In our model, all important physical phenomena are models. So you will have to transport a momentum equation, heat transfer, the turbulence, and the buoyancy. All the real equation, all the real stuff. So what you want to do, CFD, is to see what's happened far from your probe, far from your sensor, and hopefully to find where your hot and cold air are mixing, if there's backflow, and the origin of the low performance you see with your sensor. So at the end, all your data center will have a value. So you will have a heat map for all your data center, not just where the probe are. If you have a problem, you can launch a simulation and try to visually find what's happening. So for example, you can have a really large data center like that one, and the air seems well split and everything seems perfect. But at some entry, for example, in some vent, the air doesn't go in the right direction. We don't have a probe there, but we can see that the air is going back toward the crack. So what's a sensor CFD? Sensor CFD is CFD applied to AKCP Pro Server. So it has every tool to make your life easier. Since it's a specialized tool for data center, you have already programmed the rack, the crack, and the vents. You have all the same advantage as you had before. So you can access it from the web, from any location. It's run on Windows and Linux. Yeah, like I told, you have already all the tool for data center. And if some are missing, we can add them. So. Another advantage of sensor CFD that's really different from other CFD is that we use the live probe values. So when you start a simulation, you click on a button and all the data from the sensor goes in the simulation. So there's no people that walk around. There's no people that try to take measurement everywhere. There's no mistake about the units. There's no mistake about the value. Everything is taken in already put in the simulation. And the simulation is bounded by those values. That means that for the rack, for example, the value of your probe make the condition for the rack. So it's not a speculation, it's really the physical value that bound the simulation. And I think that I never saw that kind of application anywhere else. So usually when you do CFD, you got a lot of steps. So you have to draw. The draw is inevitable because we have to know what you want and what we want to model. Then you have to do the meshing. What is the meshing? Is splitting the space in a small element so that we can compute what's happening. That's what the people were computing in the picture. Then we have to configure the case, make the boundary condition, do the parallelization, and then we can run our model. And in the end, you have a lot of data, but you want to see them, so you have to do some post-processing to be capable to visualize everything. It's cost a lot of money for specialized software. It takes a lot of years to learn all the small trick and everything. And yes, you have to have a really good computer. So if you use sensorCFD, we cut most of those steps, but pretty much all of those steps. So you draw your geometry and you run. So the meshing happen again, but it's made on the server, so you don't have to do anything. Meshing is really hard to make. In fact, for a plane, it can take up for 3 months to adjust the meshing so everything is perfect and beautiful. So there's no trade-off in our software. So we use a finite volume method for the method for the equation. And we have a beautiful hexagonal mesh, which is like dice, D6 dice, which is really good for fluid dynamic. And yes, the CFD toolkit that we are using, really well studied, that it's used in a lot of fields. It has thousands of publications, so it's the real stuff that's run that. Do you have any question about CFD or what is sensorCFD? Okay, if we don't have any question, I will continue. No question? Here we go. So I will show you from the start. I will start a server with sensorCFD and then connect it to a AKCP Pro server. I will use cloud computing, but you don't have to use cloud computing. You can install it on your own computer. So this is the instruction manual. That's the magic line. We will use it after starting the computer. So I go here. That's his DigitalOcean. I find it much easier than Amazon or Microsoft Azure. In both cases, you can do exactly the same with Amazon, Microsoft Azure, or I think Google. You can create a droplet, and the trick is to ask a machine with Docker already installed. But any Linux and Ubuntu machine usually can be used. It's quite easy to install Docker in those machines. So now I will start.
And Gabriel, you can also run it from your own in-house server. You don't need to run it from the cloud.
Yes. Like I told you, if you have a computer, you can have a computer dedicated to CFD. It can run on Windows, but Windows use compatibility layers because CFD is made to be used on high performance computers, so on supercomputer, and usually the supercomputer run on Linux. But it can work on Windows with a bit of work and a bit of resource. So the server start, and once we get it, we will connect to it like that. Take the EP. So if you work on Windows, you can use Putty or any other SSH software. And that is the magic line that does everything. So you just take it and put it in the terminal. It will download everything. It's a bit large because it's a whole machine. So it has all the CFD software, all the drawing software that will be used. So it downloads everything and it will start automatically. So while it's doing that, I will go right here and I will go in the menu right there. And in server setting, CFD simulation, I can choose to use CFD. I already have a machine started, so we don't wait for the download. You can set up your IP, the power, and the number of CPU. So if you start a 32 core computer, like I just made, you can put 32. If you have less, put less. And you have the number of steps. The number of steps is linked to the quality of the simulation. But I will talk maybe a bit later about that. And once your setting is all made, you can save and go start using CFD. Everything is ready to use CFD. Okay, so I will create a new map. I have a drawing that I forgot to start on my computer, already ready. It's the, if you give me a few seconds, it's that data center. That's what we are drawing. It's look intimidating, but it will be quick. It will be really quick. You'll be surprised how easy it is. So we add data center. We will add it empty. We will make a room 6 by 6. 6 by 6. And the 8 we will put 2.6. We will put the ceiling at 2.2 meter. We will put a raised floor at 0.4 meter. And the rack will be 1.7. So next, I will assign a rack later. Finish. So that's our room. To start drawing, you have to unlock your map, then go on a pen and go in map editor. I will take a rack and put it on the map. I can edit the size of the rack in the edit menu. So now I just have to place it like in the drawing. The demo I'm doing is will be in the new version of the instruction manual, presented step by step, so you can work and try it for yourself. So 180 meter. Okay. So it's a cold containment we are doing. So the front, it will be or hot or outside, or cold side, sorry. Front is the cold side and your back the outside. So we just make a row. So useful tool right there, snap to object. So we don't have to play around too much. Then I will draw the containment right there. Take the corner and I approximate the size. I can go and edit and set the size directly. It's 112. There. Snap to object. There. Oh. And start the other row. Right there, I can flip it. So that's done. We will put the crack. So it's called containment. So we want back to bottom, back to bottom. I will adjust the size. I will change his orientation by rotating it, and then place it like in the map. So we have there 64, 56 on the top, right there. Bottom one, flip it, place it exactly at the right spot. If you do that map, you don't have to reproduce exactly what is in the instruction. It will work anyway. Should work anyway. Here we make the vent or 4. And we will put it in the containment. 36 right there. I can copy. Okay, so a good habit before starting the simulation or anything is go in 3D and look if everything is like we expect. And everything will be not like we expect because I put the vent on the top of the containment. So we see they are at the top. So I will go back in 2D and move them right there, put them on the floor, move on the floor. And we are done. We did all that complex drawing. I can show it to. So right there, we did all that complex drawing in, I don't know, 5 minutes. That was not that was quick. Okay, so when drawing is ready, we just have to start our CFD simulation, and to do so, we click on the pen there on Run CFD Simulation. So we are presented with a GUI to help us to set everything. We can click on Next if everything is like we expect. So if you have the probe already set, you can load the value from the sensor. So you click on that and everything will be filled. So all the rack will have different temperature, all the crack will have a different temperature. But since we don't have the probe, we will have to fill something by something real, something not too bad. So for the rack, we will put the inlet at 20, the outlet at 30. Since our containment is perfect and everything is perfect, the hot goes back on in or crack at the same temperature and goes out at 20 and goes back in or rack. So next, so the power we will fill again. It's about like that. So here again, if you have the probe, you load the value from the sensor directly in the form. Okay, so we use the differential in temperature and the power usage to compute the volumetric flow. It's a really important trick because you don't have to use anemometer, which is really expensive. You will use them for the crack because we want to know the real quantity of energy to remove in the server room. So that's our volumetric flow. We click finish, and then we are done. We just click on OK, and it starts the simulation. So I will just go show you the the new output. So the before the output was all junk, and now it's showing you the step and everything. But you don't have to see the server side because everything is displayed there, and we will improve that a bit. So yeah, your model is ready. Everything is ready to run. Is running right now. So a new feature now, we can export the map and import the map. So for example, if we want to take the code containment, we can export it, and we can load it like that. We can make a new hot map. We'll import. There's a lot of my computer's working a lot, so right there. So our map right there, and I will change it to make a hot containment. So right there, unlock. I will go in map editor mode. I will take my vents that are on the floor and put them back on the rack. And then if I go in 3D, I will see that my cooling units are not the right one, and that I don't have conduct on the top of that. So I will have to change my cooling unit. I will go on layout. We'll remove that one. So for the hot, we want to take from the top and send it in the front. So this is the one. 0.74, 75. Rotate it and place it like in the map to 64. 66. Make a copy. Flip it and place it. .44. Okay, like I just told, if I go in 3D, I will see that I don't have the conduct drawn on the map. So I have to add it. To add it, we just draw the vent on the top of the crack. Like that. Here we go. So we just made two maps that will be available for simulation in a really short amount of time. So our previous model is still running, but I have the result already. The result, but before it will be time for Nick to show you some other feature. Nick.
Hey, Gabriel, thanks for that. So I will share my screen. Okay. So some of you may be familiar already with AKC Pro Server. Some of you not, but I'm just going to go over some of the basic features and also some of the new features that we've just added in to APS version 16, which is what needs to be used with the sensorCFD. So as Gabriel showed, when you are setting up the CFD simulation, he input some arbitrary numbers. So the temperature of the air coming out of the crack, the return air temperature, and the power of the racks. And that's how typical CFD works. You know, you input these basic values and they give you a simulation as a picture of what your data center should be like. In real world, though, it's not like that. And that's why we call this sensorCFD, because we're using the sensor data in order to constrain that CFD model. And you saw in Gabriel's presentation there was an option to grab the sensor data. So you may be wondering where that data comes from. I'm going to show you how you would set up a rack in the drawing and add the sensors to it. So I'll go over to the cold containment. This is the same drawing that Gabriel just did. And you can see at the moment, you've got exactly what Gabriel just drew. However, there's no sensors on here. So this would run a simulation just like we're doing in Gabriel's example with some generic data. So if we want to create an actual sensor constrained CFD model, then we need to create some rack maps and add some sensor data to this map. So one of the first things that we'll need to do is to create a rack map. So under the maps menu here in AKC Pro Server, if you don't see that, then you click on this button, it will bring up this side menu. And you go to maps and select add rack map. Now, we do also have another feature where you can draw a data center quite quickly, where you just input the number of racks, number of rows, number of aisles, number of racks per aisle, and it will automatically draw that for you as a grid. And then you can go. So we're not going to do that right now because I'm using the map Gabriel's already drawn. So we'll just create a rack map. We'll call this rack map number 1. And you can enter in here some other information about the rack. So the weight of the rack. So if you have raised access flooring, there's often a weight limit. So you may want to record some of this information for later on. Also, as well, the current load of the rack. So if you are doing capacity planning in the future, you can see, well, I've got available using this rack, but I don't have sufficient power overhead. Also, as well, the maximum load weights that you can put into the rack. So we'll just leave those as default. And it shows up here now in the left side here, you'll see under rack maps, we now have rack map number 1. And all I need to do is drag this across onto the rack that I want it to be on, and it will automatically then assign this rack map to this rack. And when I double click on that rack, I can then go into this rack map here. So you can duplicate these so that you can have it on multiple racks. You can also export it. You can open the rack map directly from here. Once you've got this rack map, you then need to add a sensor to it. So under devices, here I have a SPX Plus, and connected to this, I have one of our thermal map sensors. So the thermal map sensor gives you temperature at the front, top, middle, and bottom, temperature at the rear, top, middle, and bottom, as well as the delta T values, and also humidity front and rear. So all I have to do is drag any one of those onto this rack map. So if we take temperature front, top, for example, I drag this across, you'll see that it automatically knows where it should be placed. And when I drop that there, all of the other sensors from that thermal map will be put into place. So that's quite neat. Now, another thing that you'll see is up in the upper right corner here, we now have current. So we have a contactless current meter, which you can wrap around the cable on the PDU, and it will give you the power readings. And now you don't have to splice out an individual wire. It isn't like a traditional kind of CT where you need access to an individual wire. This sensor can be put around a multi-core cable, and it's not billing grade accuracy. It's around plus or minus 5%, but it's enough for the sensor CFD to have an idea as to the power of this rack. So the thermal map sensor comes with the current meter, and you plug that into a single sensor port on the SPX. And then when you drag and drop that across onto the rack, you'll see everything just gets positioned exactly where it needs to be. So these animated arrows are showing the delta T values. So you can set the thresholds just like.
See, Nick, I hate to interrupt you, but I'm just curious. These sensor values, is this real sensors or is this some just a mock-up?
No, this is a real sensor that's currently sitting on the desk in the office. So obviously, the front and rear is reading the same temperature because they're all sitting in the same room. We don't have a live data center to put this in.
What about the current meter?
The current meter is clamped around a cable going to the computer.
Oh, okay.
So yeah, that's a real reading of power, but it's not a real data center that we've got this set up in. So obviously, yeah, in real life, what you'd expect to see at the front would be, say 20 degrees on the inlet and maybe 30, 35, 40 on the outlet.
Nick,
yeah.
Can I ask another question? So this live sensor data is in the Philippines at the factory, right?
Yes.
And where's the APS running?
This APS is running on the cloud.
So the APS on the cloud is collecting data from the factory, and you could input that data into the simulation. So, you could run everything on the cloud, you can run it locally. So this is a good demo. It's very realistic. Okay, I apologize.
So yeah, obviously in real life, you would see, values that you would expect to see in a data center. And these animated arrows show the delta T. So as with all of our sensors, you can set sensor thresholds. And so if you say, I want my delta T value to be X, and and if it's Y, then it should be giving me a warning, then these arrows will change color. And the quicker those arrows are moving, the greater the delta T gradient that you have. So the slower they're moving, the less delta T, the quicker they're moving, the higher the delta T. And they will actually go the other direction if you have a reverse delta T, which obviously you'd have something seriously wrong in your data center if that was happening. So from this rack map, you can also add assets as well. So you'll see when I mouse over it, you've got the 42 U's of the rack here showing up, and you can add assets to these. So you can use the APS as well for tracking your assets, capacity planning, and adding assets to the rack. So that's quite simple. Just add an asset, and then you input the data here. So you can give the asset a name. You can choose what type of equipment it is. So none of this is required for the sensorCFD, but this is just another feature that we've got of AKC Pro Server. So as well as being used to manage your AKCP base units and sensors, you can also use it as well as a DCIM type software to actually bring in sensor data from us. You can bring in sensor data from other places as well using virtual sensors, which I'll show you in a moment. So if you had an intelligent PDU, for example, in this rack, then you can bring the sensor data in from there. And any of that sensor data that comes into the APS can be used in the sensorCFD simulation. So if you have an intelligent PDU, you could bring the power data in from that rather than using our power meter. So it's you've got options there if you already have equipment. So you can also link the assets to a sensor. So if this was a network switch, for example, I can do a ping virtual sensor and I can check if that switch is online. It could be a server. I may be able to get an SNMP get from that server and find out what the CPU utilization is. So you can do all of those types of things here in the APS as well. You'll see a little diagram of a lock there. So AKCP makes swing handle cabinet locks. So if you have those, so you're using our access control system, that will also show up here on the rack as well. And you can lock and unlock the racks remotely from here. You can also see if they are open or closed. So there's lots of features of the rack map. And when you jump back here now to the 2D or 3D view, because we've added those thermal map sensors, you can now see a heat map. So if everything was normal, then you would see these cabinets would be in green. But we can see here we've got a high temperature on the front, and our temperature on the rear is too low. Now, if you switch to 3D, you can also see those in 3D. You see the sensor that we've placed on there, and you can also isolate an individual rack. So from the 3D view, you can double click on that, drill down to that actual rack, and it will show you here then the rack map that we just created, plus some sensor data from that rack, as well as graphs as well. And one cool new feature we just added on the graphs is to be able to show ASHRAE boundaries. So ASHRAE, the American Association of Heating Refrigeration Engineers, they publish specifications and recommendations for buildings and data centers as to what temperature you should be operating your data centers at. So we've added those thresholds, and we automatically shade the graph to show if you are within those ASHRAE bounds. So at the moment, obviously, this isn't real sensor data in a data center. So the temperature is way too high and we're outside of the ASHRAE bounds. What you want to see on this graph is everything green, showing that you're within the recommended ASHRAE temperature range for your data center. So just one other thing I'll show you, there is a lot of features here in the APS. We could do a whole seminar just on those, but I'm conscious of the time. So I'll just show you how you would create a virtual sensor, which I mentioned earlier. So if you have some third-party equipment already, you can select a virtual sensor here, and you can choose the type of virtual sensor that you want to use. So yeah, if you have a intelligent PDU, it could be an SNMP GET virtual sensor. If you have some power meters already, you could be using a Modbus virtual sensor. We can ping a network equipment and alert if it's on and offline. We can combine the values of multiple sensors. We can also use a logic, which is if this sensor and this sensor is critical, then the results should be critical. But if only one of them is critical, then the results should be normal. We can calculate the energy costs automatically. So from any energy meters that you have in the data center, you can bring those in, input your price per kilowatt hour. We can also automatically calculate PUE. So again, from all of your power meters, you can input that data, and we can show you your live PUE readings. So as you begin to make changes in your data center, you can fine tune your data center temperature values and see how that's having a knock-on effect to your PUE in real time. You can also calculate the dew point from a temperature and humidity sensor. And then if you have multiple sites, we do have a world map as well. So these maps you can drill down. So from this world map, you can drill down to a specific data center and then down to a specific rack. So if you had multiple locations, you could drag those other locations onto the map, locate them, and you can drill down, and the map will show the worst sensor status of any of the sensors that are in the submap. So from this view here, you can very quickly see if a specific location has a problem. You can drill down to that location, and you can drill down to the specific rack that has that issue there. So as I say, there's a lot more features to the APS. It could be a whole session itself, but I think we've covered enough here to give you an idea as to the power of the software and how you would create a rack map, add it to the 3D floor plan, and then add a sensor to it. So you can bring that sensor data into the sensorCFD. So Gabriel, I'll hand it back over to you.
There's a question in the chat. So to clarify, each rack requires a sensor. So yes, yeah. For the
Gabriel, if I may interrupt for a moment, I just wanted to clarify because I'm not sure if people understood. There's two levels of understanding of the data center. What Nick was demonstrating was the heat maps, which is a representation of the instantaneous sensor values that you have in your data center. And as you noticed on the heat map, it only showed the point values of that temperature right where the sensor was. That's different from what the work that Gabriel is doing. He's taking those point sensor values at a specific, location and using those values to compute the airflow throughout the data center. So there's two levels of computation. The heat map changes instantaneously all the time, immediately report any problems. The CFD simulations, depending on the power of the computer, could take an hour to run to show you an airflow, and then you could rerun it once an hour, once every 2 hours, depending on how many computers you assign to it. But I wasn't sure that everybody understood that there was kind of a difference between the technology that Nick was showing and the technology that Gabrielle is showing. They're both useful, but there's some differences. Yeah. Sorry for the interruption again.
That's okay. There's another couple of questions here in the chat as well. Mohammed, the CFD analysis, you must use the thermal map sensor, not necessarily. So if you want the sensor CFD analysis, then yes, you must use the thermal map sensor. But you can also do what Gabriel showed, which is input an arbitrary value. So this is approximately the number of kilowatts that this rack is using. And we can also make a sensor, a CFD simulation based on that, which is what Gabriel is going to show you the output of in a moment. So you've got two options there. You've either got the sensor-backed CFD, which uses our sensors or other sensors that you bring in through the virtual sensors, or just for free, you can input arbitrary values. There's another question here. Please show the PUE calculation in real time. I don't have sufficient power meters here connected up to the APS to show that, but basically you create the, see how far we can get through it. One moment. You create the PUE virtual sensor, and then you need to select the IT power sensors. So if you have power meters on all of your IT equipment, then you would select the relevant power meters for your IT load. Obviously, I don't have any here, so I can't select any. And then when you hit next, you will then have to select the non-IT power sensors, and then set what your PUE thresholds would be. Those will be your target PUEs. And yeah, then it will calculate the PUE live based on the input from those power meters. Perhaps if you're interested, we can also have another session where we go deeper into actual AKC Pro Server features another time. Are there any other questions there in the chat box? I seem to have lost the chat box, so if someone can, there we go. Will it work for an open space data center with lots of racks instead of a container? Yeah, Gabriel, I believe that it would. It's going to produce quite a messy map of mixing air, but yeah, you can run it with an open space data center as well.
In fact, that's the most interesting map for me, because you will see that when everything is well contained, it's a bit sad. The result of the thermal map is a bit sad, but yes, you can run it on a really large map, open without any containment. It will run also. Yeah, the value, when you put your own value, the accuracy of the model would be a bit lower, but if you use probe, usually the accuracy should be not that bad. There's not other question. Okay.
No other questions. So I'll stop sharing, Gabriel, and you can take over.
Nick, I think Mohammed had a question about bringing third-party power meters into our APS, and can you graph them? Can you add them to the CFD simulation?
Okay, I don't see that question in the chat, but yes,
it says Mohammed Wahid to everyone. Can you please show power data in a real time using intelligent PDU?
Right. Well, we don't have an intelligent PDU connected up So yeah, but it would be it would be a virtual sensor. So you go to add device, virtual sensor, an SNMP get virtual sensor. You could say this is a PDU power 1. You would input the IP address of that PDU, the SNMP community, the port number. When you hit next, it will then take you to the page where you would input the OID. So you would get the MIB of that third-party power strip, get the OID, input the relevant OID for the power readings, so on. And then once you've created that virtual sensor, it will show up here in the Server Explorer. So the Server Explorer window here, we've got AKC Pro Server, which will show all of the virtual sensors, and then any of your AKCP base units will be displayed down the left here. But again, I'm conscious of the time, and this session is supposed to be about sensorCFD. We could run another session where we do, more in depth into AKC Pro Server, I think, another time.
Yeah, that's great. Thank you, Nick.
Yeah,
Sorry for interrupting again.
So I'll stop sharing my screen, and Gabriel can show you the output from the sensorCFD.
Yes. Okay. Before, just another question, Nicola. The question: do you have rope leak sensor within your demo sensor?
Oh, yes. Let me share my screen again. Hold on. I think I have a water leak detection set up here. See? What sensors do we have connected? Yes, so I've got a water leak detection sensor there. So if we were to zoom into here, this is a spot water, I think, but it could be a rope water sensor. And you can drag and drop this onto the map. Now, if you want to reposition a sensor later, you can unlock it and you can drag that sensor to where it should be. So let's say, for example, you had water leak detection there in the middle of the cold aisle, could be underneath the raised access floor. You might want to put it underneath the racks. If they're spot water sensors, you might have one under every rack. If it's a rope water sensor, it would cover the whole row, for example. And at the moment, you see its status is dry, and if it was wet, then this would change red and flash and would say wet. You can also edit these markers as well, so you can change the shapes. So if you want all of your water sensors to be circles and all your temperature sensors to be triangles, you can also upload images as well if you want to have your own little diagrams and icons on there. So yeah, there's lots and lots of features of the APS, and that would be how you place a rope water sensor or a spot water sensor onto the map. So any of the sensors here from the left can be dragged and dropped onto this map. And you don't have to use this map that you've drawn. You can also upload maps as well. So you can upload a JPEG. So let's say, for example, you already had a floor plan of the data center. You could upload that drawing, and obviously you wouldn't get the sensorCFD from that, but you can drag and drop sensors and locate them on an existing map as well. You don't have to use our drawing tools. Okay.
Good. Great. So there's another question, but it's for me. So I will take it back from here. So, okay. Our simulation finished. In fact, we had enough time to finish the model. So we have our results, and I will just answer the question. So can we use sensorCFD without containment? Yes. Like I was telling, it's in fact it's the funnier result, because you will have a temperature map much more interesting. So let's see your results. We'll take that one already made. So here, once the model finished, the simulation message is removed, and you have CFD layers. If you don't see them, you can go on the pen and click on Use CFD. Each layer show you some interesting data. So, For example, we can look at the airflow around your data center. We can look at the temperature map. Like I was telling, if you use containment and everything is perfect, it's not the most interesting map. But when things are imperfect, it's more interesting. I will show you another. So airflow, like I told, airflow in X, it's much more impressive. Let's cut for the velocity. And a small trick, you can use a single rack mode to hide the rack and see all the airflow around your data center. So this, like I told, is the perfect cold containment. But we have another map right there that show containment like the first one I just showed, but our rack are lifted. For example, if they are on some wheel and there's an air gap under, and the containment doesn't, it's not blocked. The air can goes under the rack right there. So I made the model. Modeled it. We can see the temperature. Oops, I tried it. Sorry, right there. This one. I will select all of them. Okay, so now we see that we have some air mixing, some air that's get out of our containment under, and we see that the temperature is mixing. So right there, if we can look on the top, we see the air mixing right there. But you don't have to search with the map like that. We already have a tool to see the mixing. So we have that tool that show the zone where you have a high temperature variation. So it will underline, or I just removed it, and show where you got the air mixing. So if you got a good great gradient, you can see it on the map. I can moderate to see a bit more. So we see that we got a lot of mixing in that. So it's a numerical simulation, so you will always have a bit of piece like that. Okay, so here. Okay, so one of the most useful feature when you're using sensorCFD will be the temperature variation. It can show you when you got mixing, like in that situation with the air gap under the rack. But it can also show you when you do mistakes. So, for example, since I put the value myself, the value I put cannot follow the physics. So I can put junk value that are not good. When I do that, the temperature mixing show it also at the inlet of our crack and rack. So when you see a lot of red like that around your crack, you don't have the right value. It can also show you when the model doesn't follow the reality. So for example, we can look at or cold containment with problem like that. So that one. So I just show you with the air gap under, but sometimes the person that will draw the map will not put the air gap. So what happens when you do a CFD model and you draw something, but it's not the reality. For example, the containment is not perfect, the door is open, or there's a leak. What's happening is that the value of the probe that's put on your rack will not fit with reality. So the model will fail because it will try to find, for example, from, I will put the temperature variation, that tool right there, use it. And like I just told you, we see that at the inlet of our rack, we got a lot of red a lot of red. We get a lot of red on our crack. If I, sorry, I did. Okay. If I look back at our model with the gap, sorry, I have a bit of difficulty. Okay, if I look back at the model with our gap, you will see that I don't have the red on the rack because I draw the reality. So if I go there, we have a red around the hair, around the mixing of the air on the bottom of the rack, but not so much on the rack. You will see that one is completely clean. Why? Because the value I set for that inlet is close to the reality. But in the other case, the air is cold, but the model cannot understand why it's getting cold. So there's a small phenomena at the boundary that happen that you can see with the content, the temperature variation. If I take a slice of the temperature, we see the temperature goes crazy because what happened is that the model tried to compute where the heat goes. So the air transports the heat and goes in the inlet for the crack. We can see it more easily. The air comes from the crack and the model tried to compute where the heat goes, and it cannot find it. So it creates a space with a really high temperature, and the model crashed. So when that happens, you can see it. So with that hint, you can know that what you draw is not the reality, and that something is happening. Maybe a mistake for the drawing, maybe there's a leak or something open that is not drawn. Okay, I can show you some other mistakes, some other problem. For example, we can look at hot containment. Like I just showed that one has no simulation. Just open that one and go in 3D. Like you see, I have the result of those models, and all those models were computed on another computers. So the AKCP Pro server keeps the results on your computer, so you can show it to your customer. You don't have to be connected on CFD server to show them. So like that, I selection red. So you see that we don't have a lot of red. So everything seems quite good. And if I look at the temperature map, we will get the boring red and blue. Everything is perfect. But what if I forgot to put the conduct? I can open the map, go in 3D. So it's the same model, but I forgot to put the conduct. So we see right there that we have air mixing. We can use the temperature mixing, the temperature variation I to spot them directly, really easily. And we see that right there at the boundary, you see that color. The model tried to understand what's happening, but it failed. So that's why we have those big mixing cone right there. Another problem that might be funny, for example, you reverse the rack and on the hot containment, so you place the rack in the wrong direction. Right there with the temperature variation tool, you see immediately that you made a mistake. Everything is red. Everything is not good. The air is mixing everywhere. Yeah, if you don't use containment, you will have much more beautiful reading like that about the heat, how the heat is distributed. Yeah, the model is as good as what you draw, but you have some tool to see if you did some mistake. Yeah, I think I show everything interesting. So yeah, you have all the CFD layers that you wish to use. If you need something else, you can always ask. We can add it quite easily. Yeah. Do you have some question?
There is a question about using the simulation with in-row front cooling units. So that's I think we can do that.
Oh, yes,
you would just draw the crack unit inside of the aisle in the containment, and so it would be blowing its cold air into the aisle.
Oh, you can do a lot of variation. I will take that map right there. You can do a lot of variation. I show you perfect one because since I have to input by hand the value, so since I have to put the value myself, it's a bit hard to try to guess which will be the temperature of that rack without containment. Without containment, if I put the rack there, that rack there, the rack there, guessing the temperature inlet, the temperature outlet in the setup is really hard. So that's why we have the probe. When you have the probe, you don't have to guess, you just have to use the reality. But yeah, you can model everything you have in mind. So you can just do a really complex map with containment. You can use the front to back cooling unit. I think that was the question. So yes, we have front to back cooling unit. We can change the height of rack, make really complex setup. So the result will be as good as what you can put in the model. So if you don't have a real data center with that shape and you try to start the model with your value you try to guess, you will have a lot of mistake and the simulation will be not good. Yeah, but you can do anything. You can add beam, remove section of the room with the box. So you, for example, you want to add a beam. You can add a beam. That map start to be junked. I will use another one. For example, we have a beam across the room. I can add a beam, map editor, unlock, using a beam. That's the containment or the block box. Okay, you can use the box like that. Set the 8. So the drawing tool is in 2D, but you can set things in 3 dimensions. So at 2 meter high, save. So now we have a beam, but the beam is in the ceiling. Yes, if you have some obstacle in the ceiling in the floor, you can put them without problem. So the beam is in the ceiling and you can launch the simulation. There's no trick, okay? So the simulation will do what you draw. You can draw everything your imagination has. So for example, you can stack cooling unit, you can do everything. It's a real simulation behind. It will take what you give them and it will give you the result. If you put junk, it will give you junk at the end, but it will do the simulation with what you give. Is there other question?
No other questions in the chat box. So unless anyone has any other questions or anything you'd like to see again, or
yes, can we get reading for carbon usage effectiveness for each rack with your sensor and the simulation software? with the simulation software, the CFD, I think it's over computing. I think that just with the probe you can have that. So maybe Nicola, you can answer. Nick, for the question, can we get
carbon usage effectiveness? We don't have a calculation for that currently, but it could be something that we could look into. I suppose it's related to the PUE measurements. So it's something that we could look into adding in the future, I think.
So other question? If there's no other question, I would thank you to come and see our presentation. It was really nice to have so much question, really nice to have so much interest. So yeah, thank you all.
Question there?
Yes,
someone
yes.
asking for a trial version of the software. Yeah, so actually the AKC Pro Server software is available on our website. I'll type into the chat box. It's akcp.com. And if you follow under the platforms, you'll see AKC Pro Server, and you'll also see sensorCFD. So you can download AKC Pro Server. It's free of charge. You can use it with up to 5 AKCP base units, so you can play around with it. And you can also then download the sensorCFD package and add that to your installation of AKC Pro Server, so you get both. The AKC Pro Server also comes with 5 free virtual sensors. So if you had some other third-party equipment and you wanted to test it out, then yeah, you can also try it there. So yes, the trial version is available on the website, and the CFD simulation is completely free of charge. If you're hosting it yourself, running it on your own PC, the cost only comes if you wish to add the AKCP sensors to constrain the model with real life data.
That's when the CFD gets really useful. Yeah, thank you everyone. The sensorCFD module is free, like Nick told. You can use your own computer, so you don't have to use cloud computing. That can be really expensive. It's still in beta. It still have some harsh corner. Right now, for example, we already add the import export, cleaner output. Also, we had a small forum on the AKCP website. If you have question, problem, or anything, you can go there. I try to put all the information because it's real CFD. So there's a lot of situation. For example, you can have a bad meshing that happened. You can have a variable blowout. You can have a lot of small problem. It's written in the instruction manual, but yeah, if you have problem running your simulation, go on the forum. I will try to help you to set everything right. Yeah, thank you.
Hello, Gabriel.
Yes.
This is Moses from Uganda. I would like to take this opportunity to appreciate the clients I invited, and in case they need any clarification, they can reach me. Then I can share their inquiries through Nicholas, then to you as well.
Yes, you're welcome to contact us.
Yeah. Okay, thank you very much.
It's a pleasure.
Okay, well, if there's no more questions, we'll wrap this session up. I will email everybody who was on the Zoom invitation with a link to the video once it's uploaded to YouTube. If you joined the presentation with a direct Zoom link, I think not everybody here had registered. So if you just follow either the akcp.com blog or our YouTube channel, then you'll see the video presentation of this up there as well. Okay, so thanks very much, everybody, for your time. I hope you found this useful. I did see in the chat that Mohammed is asking if we could do something like this every quarter. So I think that's something that we could consider doing to show whatever, updates or latest developments we've got. We'll go over new features of the software. Okay, so thanks very much, everybody, and you have a good rest of the day wherever you are.
Thank you, Nick.